This section is 5.1, solving proportions. Okay, so the first thing that we have is definition of a ratio. So that's a comparison of two numbers by division. So we've got a couple different ways you can write a ratio out. Sometimes they'll put a number and then the word 2 in between and then 10. That could be something like that, so 15 to 10. This is also read 15 to 10 with the little colons in between. A lot of times the ones we're going to use, it would be 15 over 10 like a fraction. Since these are similar to fractions, you can also take and reduce those down. So like here, 15 and 10, you could take both of those values divided by 5, so that could reduce down to 3 over 2. That would be the same exact ratio. What we call ratios that are equal to each other is called proportions. So we know, because we can pull a 5 out of both of those and drop to 3 and 2, that those would be equal to each other. Same thing going the other way. We could take both of those values times 5 and get 15 over 10. So since both of those fractions are equal to each other, that's called a proportion. One way we can go about solving these, and I think this is one of the easiest ways to solve these, is to do cross products. Products meaning multiply, and cross meaning like diagonal from each other. So here our cross products would be the 10 and the 3 and the 15 and the 2, because those are diagonal from each other. So if we do 15 times 2, we get 30, so product means multiply. If we do 10 times 3, we get 30 as well, so both of those end up equaling each other. Now that's convenient if there's a variable in there that we're trying to figure out or we're trying to solve for. So what we can do is we can use cross products here. So we've got 9 over m is equal to 63 over 35. So what you could do here is you could take and multiply the 63 and the m and the 9 and the 35. So if I write that out here, 63 times my m is equal to, and then my 9 times my 35. So if I kind of solve this out here, I'm going to have to go 9 times 35, which you can just use your calculator for that, which is 315, is equal to 63m. And then to get rid of multiplying by 63, just like the equations we've done before, we divide by 63 on each side, because then the 63's will go away there. We'll have just an m is equal to, and then if we take 315 divided by 63, our m comes out to be 5. Now if we think about this logically, if I had 9 and then instead of the m I put a 5 in there, is equal to 63 over 35. If you think about this, to get from 9 to 63, we would have to multiply by 7. Same to get from 5 to 35, we would also have to multiply by 7. So there's other ways around this. Besides using cross products, you could kind of just use logic and go, okay, I got to divide by 7 to get there. So if I do 35 divided by 7, I would get 5. Lots of different ways that you can do proportions. I'm just going to do cross products because that's the way the book kind of wants it to be taught. But there is lots of different ways to do this. Okay, so the next one here is a little bit tricky because we've got a couple variables in there, and then also we've got a variable and then minus 9. So what I'm going to do is I'm going to think of that z minus 9 as like a group, and then I'm going to do my cross product. So I'm going to do my z minus 9 as a group times my 5 and my 4 times my z. So if I set this up here, thinking of that z minus 9 as a group, it would be 5 times that group of z minus 9 is equal to, and then the other one I'm multiplying would be 4 times z. So again, now this is just like an equation. So we've got distributive properties, so we take the 5 to the z, 5 to the minus 9, so that would be 5z minus 45 is equal to 4z. And then we would want to get the z's on the same side, so we would subtract 5z from each side. I didn't move that one because then there's 0 over there, which we don't really like working with, so I wanted to move the 5z. So when I subtract there, the 5z's will go away there, and I'll be left with negative 45 is equal to, and then if I did 4z minus 5z, that would be a negative 1z or negative z. And then to get rid of the negative 1, divide by negative 1 on each side, so my z would equal 45. And if you plug back in there, just like we kind of did before, both of those fractions would end up equaling each other. Okay, so if you want to, you can, but you don't have to. Okay, next thing here, On page 189, try out A through C, and I'll get you the answers here. So for A, they got 4. For B, they got a decimal of 87.5. And then for C, they got 5. So hopefully you got those ones. Okay, another way that we might use proportions would be to convert measurements, okay? So like I said, there's other ways to do this, but proportions is just kind of what we're talking about in this chapter, so I'm going to do these in terms of proportions. So what we want to figure out here is we want to figure out how many quarts are in 15 pints. And our conversion here that you would find in, like, you know, online or like in the back of a cookbook or something like that is 1 quart is 2 pints, okay? So using our proportions, what we can do is we can set these up as fractions. So if I know that 1 quart, which is QT, and 2 pints go together, so 2, and I think that's PT for pints. So 1 quart and 2 pints go together. Now what I can do here is I can line up my quarts here, which quarts in this situation is what I don't know, so if that's what I'm trying to find, that's what my variable goes. So X quarts, and I know I'm comparing that to 15 pints. Okay, so now I can just do my cross products, where I do my X times my 2, and my 1 times my 15. So I'd have 1 times 15 is equal to X times 2, so that would just be 15 is equal to 2x, divide by 2 on each side, x would be equal to 7.5 quarts. Spell that right? No, I'm missing an R in there. Quarts. So 7.5 quarts is the same as 15 pints, and that makes sense. If 1 quart is 2 pints, it would make sense that it's going to be a smaller number there for the number of quarts. Okay, it'd be half as much basically. Okay, we'll try another one here. So we got millimeters and meters. So 1,000 millimeters is 1 meter, and we want to convert 4,750 millimeters to meters. So same situation, we can take our things we know, go together. So we could go 1,000 millimeters is the same as 1 meter. Okay, so that could be one fraction, is equal to, then if we have millimeters on the top here, we want to make sure that we have millimeters on the top of our other fraction. So if we line that up there, our millimeters that we're looking for here is the 4,750, and we don't know how many meters that is, so that would go with our X. So the important thing here is that you're lining up those labels with each other. Okay, so millimeters, millimeters, meters, meters. Then again, we just do our cross products. So we'd be multiplying those guys. So it would be 4,750 times 1 is equal to 1,000 times our X. And then that would be 4,750 is equal to 1,000 X. And then to get rid of multiplying by 1,000, we would divide by 1,000 on each side. So then our X would be equal to, when we divide that out, 4.75 meters. Okay? And like I said, there's other ways to do this. You can use multiply and you can use divide to do these out as well. We're just doing proportions because that's what the chapter in the book is about. Okay, so we'll try some here. So on page 190, try out D through E, so D and E. So for D, they got 0.96 meters, and you would have that same conversion as you did on the last one of millimeters and meters, so 1,000 millimeters, or no, actually it's centimeters there. So that for that one for D, there's 100 centimeters in 1 meter, so you can use that conversion for D. And then gallons to quarts. Ooh, I don't know if I know gallons to quarts off the top of my head. I think gallons to quarts is 1 gallon is 4 quarts, I believe. So 1 gallon is equal to 4 quarts. So use that conversion for E, and then when you solve it out, it should be, if I did that conversion right, and you could always Google it as well, should be 8 quarts for E. Okay, another thing that goes along with the proportions is ratios and rates. So rate is a ratio of two measurements having different units of measure. Okay, a pretty common one with this would be like miles per hour. So if you think like 200, we'll go or not 200, 120 miles in 2 hours. Okay, so see there how both of those measurements have different units. This one's in miles, this one's in hours, so like a measurement and a time. So that would be called a rate because it has different labels there, and they're not like the same type of thing. So they're not both time or they're not both distance. They're separate things. So anytime we have a rate, again, we can turn those into fractions. So you could do it like 120 miles over 2 hours. Those would be the same thing, and that would be considered a rate. Now, a unit rate is what we're going to kind of focus on with this. So a unit rate is a rate simplified so that the denominator is 1. Okay, so denominator is the bottom of a fraction. So if we look at our rate up here of 120 miles over 2 hours, basically what we want to do is figure out how many miles it would be if we went 1 hour. So unit rate is basically where we have 1 of whatever the bottom number is. So 1 for the denominator or the bottom of that fraction. Well, if we think about it, to go from 2 to 1, we would have to divide by 2. So if I took 120 and divided by 2, that would be 60, right? So if you went 60 miles an hour in 2 hours, you'd go 120 miles. You could use cross products on that. You could do division like I did. You could think of it kind of like multiplication. But the important thing there is unit rate is when we have a bottom number of 1 for whatever our rate is. So in this case, hours was on the bottom, so we wanted to get it down to 1 hour. Okay, so let's try another example here. So we've got the density of copper is 8.9 grams per cubic centimeter. So I'm going to write that. So 8.96 grams is G. And then when it says per is another word for divide. Okay, so if they say per, that's like divided. And then cubic centimeter, so that's just 1 cubic centimeter, and that's written as centimeters to the power of 3. So 8.96 grams is the same as 1 cubic centimeter for this copper. And then it says, suppose you have a piece of copper whose volume is 25 cubic centimeters. So we're going to go equals, and then we're talking about we've got 25 cubic centimeters there, so we're going to go 25 centimeters cubed or cubic centimeters on the bottom, matching up those labels. So centimeters, centimeters. And now we're looking for, it says how many grams of copper do you have, so we're looking for the amount of grams. So what we want to do here is we want to do our cross products, so we would do 25 times our 8.96, and then we would do x times our 1, and then we probably have to use our calculator on that. 8.96 times 25, which would be 224 grams, is equal to x. See ya. And that would be our solution. Okay, so 224 grams is how much would match up with 25 centimeters cubed. Okay? So the big thing with that, again, is just lining up those labels. If your labels are lined up, you're okay. Alright, what do we got here? We got one more kind of like this as well. So we got a trucker drove 210 miles in 5 hours. At this rate, how far will he travel in 1 hour and then 8 hours? Okay, well, if we figure out how far he can go in 1 hour, we could use that to figure out how far it is in 8 hours, right? So if our trucker is driving, we'll set up a proportion here, or a rate, 210 miles, and we know that that's happening in 5 hours. If we want to figure out what it is for 1 hour, our hours would go on the bottom here, so 1 hour like that, and then we're looking for, so that's our variable, the amount of miles that goes with that. So we do our cross products again of the x times the 5, So 5x, and then it would be 210 times 1, or we really know that to be 210, right? So we could probably just skip that step. And then again, so like in equation, to get rid of multiplying by 5, we would divide by 5 on each side. So x would equal, what would that be, 42, I believe. So if we are going, we'll write this off the side here, if we are going 1 hour, that's going to be 42 miles. So if now we're thinking, okay, I need to go 8 hours doing the same speed there, I could just take this value here for our 42 miles, take that times 8, and that would give me how far I can go in 8 hours. So that would be 336 miles. You could also set up a proportion just kind of like we did on that first one, so you could do like 210 miles over 5 hours is equal to, and then you could, instead of putting the 1 there, you could put 8 hours there instead and figure out your miles as well. So 210 and your 8 multiplied, 5 and your x multiplied, and you would get the same thing of 336 miles. Okay, so that is your book page assignment, page 192, 16 to 52 even.